Welcome to 96. More of the same, really, but a slightly different twinge to it. Tinge? Slightly different hue. A little bit more focus on applications and context. What can we do with lines? Whereas in the 95 part, it was more how do we do with lines? That's bad English, but it works. So let's start with number 1. Match the graph to the equation by putting the letter below the equation. So we're going to start with what we know about this and look at what are the differences with the graphs. So we have 4 graphs. Notice in this first graph has a positive slope. The second graph has a negative slope. Third graph has a negative slope. Fourth graph has a positive slope. How do I know that? We always think left to right in math. So you think about a person walking left to right. They're running up, right? They're going left to right. Are they going uphill or downhill? They going uphill, that's positive slope. Downhill, that's negative slope. So in the first one, they're going up. Second one, they're going down, right? They're going over to the right, left to right. Uphill positive, downhill negative. So in number 1, we're looking for a graph with a negative slope. Y equals mx plus b. Where m is the slope, so we know our slope is negative 1/3 here. We go down 1, right 3, or up 1, left 3. Doesn't matter which part gets the negative. You could write this as negative 1/3 or 1 over negative 3. You'll get the same result. And we know our y-intercept is negative 2. Well, this graph, the second one is a y-intercept of negative 2, and this fourth one also has a y-intercept of negative 2. So which one is it? The one with the negative slope. Our slope should be down 1, right 3. So B is our answer. As you can see, again, there's 2 ways of looking at it, down 1 and right 3. Down 1, right 3, down 1, right 3, etc. Or you can think about it as up 1, left 3. Up 1, left 3, up 1, left 3, etc. Should check out either way. Number 5 is saying we can use lines to model some stuff. What does the slope and y-intercept kind of represent in context? Let's look at 5a and 5d. How much would it cost to rent the car but not drive it? The cost is C up here. The cost C of driving a moving van M miles is represented by an equation. Again, this is cost. This is how many miles. So how much would it cost to rent it and not drive it at all? Well, not driving it at all means the mileage would be 0. What would the cost be? Well, it's just C when M is 0. 0.58 times 0 plus 52. Oh, the cost is going to be $52. So the y-intercept is just the cost, the flat fee of renting this van. Okay? Because, this is very common for rentals, is you do pay a flat fee and then you also pay for the mileage. And that's what lines are. Or you could pay for other stuff too. Usually it's just flat fee and mileage, which is why when I rented a moving van from Wyoming to Washington, it was much more expensive than renting a van from or a truck from one place in Washington to another. They advertise, right? Hey, it only costs $20 every day. But if it costs $500 per mile, that's an exaggeration. But, it's not going to be as cheap as you think. But that's another day. So our answer is just $52. And then that kind of ties into letter D. What's the slope? Well, y equals mx plus b. This is our slope right here. Slope is 0.58. There's a couple of ways that you can think about this. What does it represent? Well, it represents, well, every additional mile that we go, we have to pay 58 more cents. You could see that a couple ways. Slope in general is rise over run. So we can write this as 0.58 divided by 1. No fancy funny business here. Any number divided or multiplied by 1 is the same thing. So we go up 58 cents and right 1. Every increase of a mile means our cost increases by 58 cents. So a couple of ways of saying that. It's the cost per mile in dollars. $0.58 is 58 cents. Those are our two answers. Next up, I want to look at number 8, wherever that is. Give and correctly label the x and y intercepts of each line if they exist. Don't graph it. So it wants you to do it by hand, like we did in the last video. Okay. Remember the x-intercept? That's the point where y equals 0, because it crosses the x-axis when y equals 0. Right? This is our x-axis up here. This is the y-axis. So if the y value is 0, we must be somewhere down here. That's a different problem. This is a graph for number 6, but the axes are the same. So we go 2x minus 5 times y, and specifically here we're looking when y equals 0, equals negative 10. Do order of operations. 5 times 0 is 0. 2x equals negative 10. Divide both sides by 2. We're going to get x as negative 5. So it wants us to correctly label our answer. So we're going to say the x-intercept is the point negative 5, comma 0. We'll do the same thing for the y-intercept. I've already done this, so I'm not going to do it again. But remember, y-intercept is when x equals 0. Do the same calculations over here. Fill in your answer. And that's what number 8 is going to look like. For number 11, give the slope of the lines between the 2 points and circle A, B, C, or D, where A means the graph rises left to right. B means the graph falls left to right. So again, rises left to right. That's the guy going uphill. Falling is going to be the guy going downhill. Horizontal is a flat ground, no slope, flat ground. Vertical line, infinitely steep. Time to go rock climbing. Well, I say that, but I like rock climbing vertically, but a lot of times rock climbing is like worse than vertical. You're going upside down. All right, anyway, that's neither here nor there. It wants the slope. So the slope is rise over run. Well, rise is just, what's the difference between the y values? What's the difference between the vertical part? Well, there's a very common formula for that. y2 minus y1 over x2 minus x1. And it looks kind of weird, but it's simpler than it sounds. y2 is just the second y value. y1 is just the first y value. x2 is the second x value. x1 is the first x value. So if we use this formula, the second y value is 7. The first y value is negative 3. So we're subtracting a negative 3. Subtracting a negative is the same as adding a positive. Subtraction is just opposite. The opposite of an opposite is the posit. I don't know how to say it. If you turn around twice, you're back to where you started, all right? And the x2 is 4 minus x1 is 4. So we get 7 plus 3 is 10. 4 minus 4 is 0. Dividing by 0, we got a problem. This is undefined. we're all rise and no run. We're rock climbing. All rise and no run. Right? We're going up and we're not going to the left or right. Rock climbing time. Perfect. Infinite slope. We're going vertical line. Okay. So the slope is undefined. And we're going to circle D for vertical line. This is just the line x equals 4. Looks like this. I'm going to go rock climbing tomorrow. I went rock climbing yesterday. I got rock climbing on my mind. Okie dokie. What else do I want to do on this one? We just did 11. Let's do 17 and then 23. So match the statement on the left with the equation that describes it algebraically. Some equations might be used twice and some might not be used at all. So Randy is seeing her sales increase by 40 boxes every week from her original sales of 12 boxes. Her sales started at 12 boxes and are increasing by 40 every week. It's going to be kind of similar to what we did in number 5. Right, number 5, the cost starts at 52 and goes up by 58 cents every mile. So these are all just kind of lines like this. Y equals mx plus b. B is the y-intercept. It's the starting value. M is the slope. How fast it's changing. So it's increasing by 40 boxes every week. Increase means positive. 40 boxes per week. That's going to be our slope. Original sale of 12 boxes. That's our starting value. So we know this is going to be y equals 40x plus 12. And they might use different letters. Maybe the sales is S. Maybe the boxes is B. Okay, there might be, oh wait, they're all X's and Y's here on the right. So we should have y equals 40x plus 12. There it is. That's our answer. B. And again, for basically every matching problem, it really is easiest, I think, to just find the answer and then choose it. I think it's much easier to make a simple mistake if you try to find the B before doing the work yourself. All right, last one. Find the equation in slope-intercept form, y equals mx plus b, with the given information. So the slope is 1/2. M is 1/2. Slope is m. And it passes through the point 4, -5. Two ways of doing this. There's more than two ways. The two ways that I see. One is you could start with y equals mx plus b, and we know m is 1/2. So replace m with 1/2. And then we just have to find the b. Another is there's another, again, we're not looking at 24 in this video. There's another formula, y minus y1 equals m times x minus x1. This is called point slope form. I love it. Not many of my students love it. So if you love it, let me know. I'd love to get more people loving point slope form. Because x1 just means our first x coordinate. Y1 just means our first y coordinate. You can plug everything in there and solve for y. Or you could plug in x and y into this equation and find b. Both are going to get you to the same spot. The y value is -5. The x value is 4. You could solve for b. Or you could say the y value is -5, slope is 1/2, and the x value is 4. And you could solve for y. So these are the two methods. I'll just do the one on the left. You can do either one. -5, half of 4 is 2. Subtract 2 from both sides, and we get -7 equals b. So b is -7. So in slope-intercept form, we get y equals 1/2 x plus a -7. And remember, plus a -7 is the same as just writing -7. That's our answer for number 23. Hopefully this helps, refreshes your memory about lines. If you have more questions about it, remember there are the full videos as well. And believe it or not, you can also ask me questions. Whoa, cool. All right, so good luck. Please don't hesitate to reach out and have a good one. I can't figure out where, all right, I found my mouse.